Then easily I can get the solution. Next, further information we can be assessed by using this is a total information. That relation is called as the sequence expressions of the sequence recurrence relations. We can write that recurrence relation is a an equal to an minus 1 plus 4 for all n greater than 1. Here, for example, this is a, if I take that is a n equal to 1, what happens? A naught. A naught is a starting itself as a 1. If I take that, it is a 1 plus 4 equal to how much? 5. That is comes to the A1. It is the second number. Next, the third number, if I substitute, it is a 5 is a, I got it the second number. That is a an minus 1 is a 5. 5 plus 4 equal to how much? 9. That is comes to the third number.
Hello, sir.
Hello, ma.
Sorry to interrupt. Are you sharing your screen, sir?
Yes, yes. Already shared. I shared the screen.
Okay.
Not visible.
Yeah, able to see, sir.
Yes.
Oh, I'll check my phone from my side.
Disconnect and rejoin. We're able to see.
When, sir, is it visible screen?
Yeah, yes, sir. Yes, sir.
Yes, sir. Yes, sir. It is
Yes,
visible.
sir.
Okay, fine. Thank you. Here, 1, 5, 9, and 13 will be there. So on continuation. That is a recurrence relation means it is a past information based on the present information we want to be identified. And future estimations it is needed. That is a present information based on that future information we should be expected. That kind of the expression, and the expression means it is the equation we want to be developed. That is called as a recurrence relation. Recurrence relation. That recurrence relation is the an equal to an minus 1 plus 4. So here a naught, it is a starting point is a, it is a n equal to 1 I substituted. N is greater than or equal to 1 means it's a 2 I am substituting. 2 minus 1 equal to how much? 1. Here a2. A2 equal to a2 2 minus 1 means a1 plus 4. A1 equal to how much? 1. 1 plus 4 equal to 5. So second term is I got it that a2 is equal to the 5. Third term, if I need, that is a 9. It is a 5 I will substitute. Second term. 5 plus 4 equal to how much? 9. So it is a an is a third is called as a 9. Recurrence relation number is 9. So here I will substitute the 9 instead of n minus 1. Now I will get that is a 9 plus of 4 equal to how much? 13. So I am getting the sequence. So future expressions is a, this is a comes to the recurrence relation generalization. I can write this is a an equal to an minus 1 plus 4 is the following. So this is comes to the one kind of the function reference function we should be developed. That recurrence relation is a depends on that. It is the previous information based on that present information we should be get it. This is the overall idea about this recurrence relation. Here, this is the one idea of the recurrence relation, how we can be get. Second is comes to the Fibonacci sequence. Fibonacci sequence means it is a fn equal to fn minus 1 plus fn minus 2. This is a formula for that. It is a any two terms. It is a previous two terms. It is a previous two terms based adding of that. I will get that is a new term. Previous two terms. For example, it is a 1 plus 0 plus 1 equal to how much? 1. 0 plus 1 equal to how much? 1. So next to second term, it is a first 0 is the first term, second term is a 1, and the third term is a I got it that is a 1. So if I added that is a next term, 1 plus 1 equal to how much? 2. And 1 plus 2 equal to how much? 3.
3.
So like it is a
2
plus 3 equal to how much? 5. That is comes to the one kind of the recurrence relation. That relation is a function is a represented into the fn equal to fn minus 1 plus fn minus 2. This is a information about that is a recurrence relations, how we can be formed. Okay. Now, coming to the next topic is comes to the is a resolution. Recurrences is a relation, is a definition and examples. So just now I give here examples I am taking. Definition sometimes you will ask. The recurrence relation is a formula is related to the nth term. N is greater than or equal to 1 of the sequence. N.Sc equal to bracket of an. And n equal to 1 to so on to 1 or more of the terms a1 so on an minus 1. The equation is a an plus 1 equal to 3 times of an, and n is greater than or equal to 0 is a recurrence relation. This is also one kind of the example for the another. Just now it is a third example. Here previously I gave that is a 2 example. It is a third example is comes to the here 18.3.2. It is a an plus 1 equal to 3 an. This is comes to the recurrence relation. Here for example, it is a continuation. Here a naught equal to 5, I am taking the starting point. Here, what is that is a naught equal to 5. It is a n equal to 0 if I substitute. It is a naught equal to 5 I substituted. 3 5s are how much? 15. That is comes to the second term. Third term is a 15, 3 is a 45. Like that 45 into 3 comes to the next term. So it is a geometrical progression. It will be represented that it is a an plus 1 equal to 3 an. That is comes to the one kind of the relation. Now coming to the another example, it is a Fibonacci sequence. This is comes to the Fibonacci sequence. 1, 1, 2, 1 plus 1 equal to how much? 2. 1 plus 2 equal to 3. And 2 plus 3 equal to 5. And 3 plus that is having 18.3.3. And 3 plus 5 equal to 8. So this kind of addition is comes to the one of the relation. That relation is comes to the recurrence relation. We call that recurrence relation is comes to the here Fibonacci sequence. The future estimation of the function is comes to the Fn equal to Fn minus 1 plus Fn minus 2. This is the overall idea. Next is coming to the R into An minus 1 equal to 1 plus R into An minus 1. So A0 equal to P and A1 equal to 1 plus R into P plus A2 equal to 1 plus R into A1. So on. This is a generalization recurrence relation is comes to the geometric progressions. It is a 1 plus R whole to the power of N into P. That is comes to the recurrence relation. This is one more example. Now another example is comes to the here. Sometimes it is a recurrence relations is a depends on the Dn equal to last you can see here. I highlighted it is a Dn equal to n minus 1 into Dn minus 1 plus Dn minus 1 into Dn minus 2. For is n greater than or equal to 3. This is comes to the recurrence relations. Now here these all are the examples of the recurrence relations. Here examples we can see. First one is comes to the 18.3.6. An equal to R into An minus 1. And 2 is a An minus 3 times of An minus 2, An minus 1 plus 2 times of An minus 2 equal to 0. And the third is a An minus 3 times of An minus 1 plus 3 times of An minus 2 equal to n square plus 4. And fourth is a An minus 3 times of An minus 1 whole square plus 2 times of An minus 2 equal to 5n. So this is comes to the continuation of the recurrence relations. Now coming to the here, let it is a definition of the classifications of the recurrence relations. With this, it is a linear recurrence relation and a non-linear recurrence relations. First one I will go through. This is a linear recurrence relation. Here linear recurrence relations means this is a linear recurrence relations. See here it is a comes to the n is n and k be the non-negative integers. The recurrence relation is of the form. It is a C naught of n an same relation. Previously what we have same. Here that is a total all terms is together taking the one side. It is comes to the implicit function equal to 0 form I am writing. Otherwise, it is the left side is a one function and a term function and a recurrence relation. Right side is another function. So this is comes to the another form of the classifications of recurrence relations. So here C naught of n into an plus C1 of n into an minus 1 plus so on. Ck of n minus k equal to f of n. Where C naught of n comma C1 of n plus k of n so on Fn are the functions of n. It is said to be a linear recurrence relation. Next, it is comes to the definition. N comma k are the non-negative integers. It is comes to the here recurrence relation is the definitions. Whenever it will ask you, you can write like this. This is comes to the recurrence relations. What are that? It is a all C naught of n and C1 of n minus Cn of n and Ck of n are the functions and f of n also function. Right side is also easy. So right side is there. It is called as a non-homogeneous recurrence relation, and it is a right side. Some cases are zeros. Previously, I explained that is a zeros terms. Zeros terms means it is comes to the it is a linear recurrence relation, but it is a homogeneous. It is a here non-linear here. This is also linear recurrence relation, and it is comes to the f of n. F of n is the right side will be there. It is comes to the non-homogeneous recurrence relation. Now coming to the here see if C naught of n comma Ck of n are the not identical 0, then the linear recurrence relation is said to be of the degree k. If C naught of n, C1 of n, Ck of n are the constants, then the relation is called as a linear recurrence relation with the constant coefficients. Here C naught of n and Ck of n are the not identical 0, then the linear recurrence relation is said to be of the form of it is a degree k. If it is a here C naught of n plus C1 of n so on plus Ck of n are constant, then the relation is called as a linear recurrence relation with the constant coefficients. Now here example, if I take that as example, it is a recurrence relation is a above is a an minus 3 times of an minus 1 plus here 2 times of an minus 2 equal to 0 is of the order degree of the degree is a 2 and the relation comes to the an minus 3 times of an minus 2 equal to n square plus 4 is a degree 2. Degree is a 2 because of here n square is there. So it is above is comes to the homogeneous recurrence relation of the degree 2 because of how many terms are there. It is a an minus 1 and an. It is a relation depends on that is a an minus 2 and an minus 1. So 2 terms it is a depends so that it is a an is having the degree is 2. Next here it is coming to the degree. This is also here the relation is a bottom is I am giving the one more example. So here an is equal to an equal to here 3 times of here an equal to here 3 times of my an equal to 3 times of an minus 1 plus 3 times of an minus 2 equal to n square plus 4. It is clearly, it is a represented that it is a left side term is a linear form, because of here 2 terms will be there, depends on the an minus 1 and the an minus 2. So it is comes to the degrees 2. Now it is coming to the here n square plus 4 is of the degree 2. This is comes to the, it is a linear, non-linear recurrence relations. Now,
Sir, how to know about the degree?
degree means it is a depends on the terms. It is, for example, if I want to, that is a 5 terms. 5 terms I want to be added. At the time degree goes to the 5. So degree importance means it is a number of terms is needed. A number of terms it is there depends on that. Depends on that. Okay.
Sir, number of terms, is it LHS or RHS?
LHS, LHS.
Oh. Okay, sir. Thank you.
Now
Sir,
it
but
is a
when, in that 18.3.9, second one, an minus 3 into an minus 1 plus 2 of a, 3 terms are there, no, sir? Then how can we can know that it is?
Yeah. Okay, it is a which one you want to be expect? Future term you will be expect. Here you want that is a AN. You want to identify AN.
Okay.
Identify AN means it depends on the another 2 terms.
Okay, sir.
Are you getting point?
Thank you, sir. Yes, sir. Yes, sir. I understood.
So depends on that. It is a, we can get that is a 2 types, 2 constants also.
Okay, sir. Thank you,
Right,
sir.
it is coming to the here an minus 2 recurrence relation about that an minus 3 times of an minus 1 plus 2 times of an minus 2 equal to 0 is of the degree 2. The relation is a an minus 3 times of an minus 1 plus 3 times of an minus 2 equal to n square plus 4 is a non-homogeneous. Here clearly f of n equal to 0, then the recurrence relation is said to be a homogeneous. Otherwise, it is called as a non-homogeneous. It is a function is f of n is not equal to 0. It is comes to the non-homogeneous. Okay. Now solution of the recurrence relations I want to identify. The solution of the recurrence relations means it is a an equal to first term. So the first term is a coefficient is a x square I will take. So that it is a x square. Now you observe that it is x square minus 5x plus 6 equal to 0. X square minus 5x plus 6 equal to 0. This is called as a algebraic equation. Finding of the solution to the equation amounts to the fixing that is the 2 values of x that satisfy it. It is a minus 3 comma minus 2. Similarly, suppose you have to the recurrence relation an minus 5 times of an minus 1 equal to 0 and n is greater than or equal to 1. Now it is finding the solution of the relation amount of the finding the defining this one. It is a non-negative integers. Now here if I take that is it is clearly one observation. Just you observe that is one of the solution how I can get it. See here an minus 5 times of an minus 1 equal to 0 will be there. That is comes to the equation recurrence relation. I want to identify the solution. What should I take that is a an equal to? Then I can become it will become the 0. It will become the 0. Here an equal to if I take that is a 5 power n. 5 power n if I substitute, where I should substitute here an minus 5 times of n minus 1. An equal to how much? 5 times 5 to the power of n minus 5 into here 5 to the power of n minus 1. Here right side is a second term is a 5 to the power of n minus 1. 5 to the power of n minus 1 already before 1 terms 5 will be there. Bases are same, powers added. 5 to the power of n minus 1 and 5. Total is a 5 power n. And an is also 5 power n. 5 power n minus 5 power n. How much it becomes 0? It means that it is an equal to 5 power n. If I take, it is clearly satisfy the recurrence relation. That you can see here, since this is a reason. What is that? An minus 5 times of an minus 1 equal to 5 power n minus 5 into 5 to the power of n minus 1 equal to 0. So here, what is the Cn? Here clearly I got the solution is an equal to 5 power n is our required answer. But it's a here it is a how many what is the degree of this is a recurrence relation? Just now we discussed here number of the terms except the first term. What term? It is a one term is depends on how many terms, that is called as a degree. So that it is a an minus 1 is clearly depends on the an. Sorry, an is clearly depends on the an minus 1. So it is a degree is 1. So here one constant I can get and one solution point I can get. So that here 5 power n is a our solution point, and its a constant is a C. So C into 5 power n is called as a solution of an. Solution of an. This is comes to the recurrence relation solution of the equation an minus 5 times of an minus 1 equal to 0. Amma, understood no?
Yes, sir. And only 1 degree
Yes,
unte
sir.
1 sir.
Yes, directly one will be there. Here, 5 times of an minus 1 is only 1 degree. So that one constant is a C, and its a solution you should identify. You should identify solution. Is it clear? Here,
Yes, sir.
sir, is it correct? Is it satisfied? Means yes, exactly. It is a solution is clearly satisfied. I substituted here. I can get it.
Yes.
An place it is a 5 power n and minus 5 into 5 power n minus 1. So here it is become 0. Is it clear? Now,
Sir.
Sir, one doubt here. Actually, for the capital A function, we took a power n is equal to 5 power n.
where is
That's
capital A?
how. Sorry, sir. Here, actually, in the middle, we took an is equal to 5 power n now, sir.
Yes, an is a 5 power n.
That how we will be knowing that we have to take 5 power n?
Yes, here it is a based on the substitution method. Mathematical induction, what it will be decide? N equal to 1 is a true, n equal to 2 is a true, n equal to k is a true, k plus 1 also true, you are saying.
Also true. Yes.
How you know that is the n equal to 1 is true? Just you are substituting and telling that
Substituting n
it is true.
equal to 1.
So here also we are first testing that it is a substitution method. Recurrence relations, which is a substitution method, also one of the solution method. Is it clear?
Yes, sir.
Now
Thank you.
I'm going for that is the next is sorry, here every time we will go for the substitution. No. Actually, we have a certain methods. There I am going first initially how we are getting the solution. Just I explained for here. Next, here example, in the case of the recurrence relation, an square plus an minus 1 square equal to minus 4. This is also one kind of recurrence relation. This is a recurrence relation. There does not exist the real value of the function f. Because of here I am getting the minus 4 now. Minus 4. Is it the recurrence relation? Yes, it is a recurrence relation only. This relation does not have a solutions because of minus 4. Minus 4, it is a all the recurrence relations, already squaring methods, already squarings. So these squarings are the not satisfied. Squarings are the not satisfied. Squarings are the not satisfied. So the recurrence relations is does not exist the real valued functions of f, such that it is a fn square plus fn minus 1 square equal to minus 4. This relation does not have the solution. In this slide, the discussions we can now give that is a formal definition of the solution of the recurrence relation. Sir, it is a any number you substitute. Can we get the minus 4? Can you check it? An square plus an minus 1 whole square equal to minus 4. So this is a impossible situations also. So impossible situations, some recurrence relations may not give that is a solutions. That is a one note point you should be remember. Now I'm going for that is a recurrence relations. All will be the how we are getting it is comes to the sequences. So definition is a recurrence relations means as per the set we can get that is a recurrence relation. Any doubt? Anyone?
Yeah, I was just about to ask. So
please.
n we are taking only as a real number.
Yes, n is also belongs to R only.
Okay.
Real number in the positive real numbers. Then
Okay.
only here A naught, A1 and A2.
Yeah.
Okay. That can be clarified into the next where we are getting the solution. But here the real number only positive real numbers. That is here real no need to go for the real numbers. Integers, positive integers. Here see here S is a subset of set of non-negative integers. Non-negative integer. Non-negative integers means what is that? Positive integers. 0, 1, 2, 3, so on only. Only. Is it clear? So
Yes,
it is
yes.
now it is a definition of the recurrence relations means we can write this is a definition on the based on the sets. Based on the sets. Based on the sets, we can write that the recurrence relation is this one. Is it clear? One second.
Okay, sir.
fine. Now, here this is one of the examples for how we can get the recurrence relations. And what is recurrence relation? What is the sequence of the recurrence relations? How the sequence terms how we are getting, and solution of the recurrence relations I'm explained. And homogeneous recurrence relation means it is a right side term is equal to 0, and right side is having the one function. It is comes to the non-homogeneous recurrence relation. Linear recurrence relations means it is only the a power n plus a1 whole to the power of n, a1 whole to the power n minus 1, a n minus 1, a plus a n minus 1 plus a n minus 2, like the terms will be there. Then it is comes to the linear recurrence relations. Now coming to the problem solving. Here, your friend said that is a sir. It is every time we are getting that is the same way procedure. Only finding of the solution. Yes, here we will go for that. This is a way of approach for the finding of the solution. Now I tell you that it is a short way of the form how I will get the solution. First example you can take here. Consider that the recurrence relation an minus 7 an minus 1 plus 10 an minus 2 equal to 0. This is a clearly recurrence relation. This is a recurrence relation. Fine. Is it the solution? Can you see that it is a yes, equal to here? How many terms we have? What is the degree of this recurrence relation? 2. Because of an depends on the 2 terms, so that it is a degree is 2. So the degree is 2 means it is a 2 constants are needed. Yes, 2 constants are available, and we want to find out that is a 2 and 5. These all are the roots of the above quadratic equation. For example. All of you note it down here. It is a an equal to x square. All of you note it down on the paper, in your paper, on anyone's paper. An equal to x square minus 7x x square minus 7x plus 10 equal to 0. X square minus 7x plus 10 equal to 0.
Okay.
Now you solve this equation.
5 and 2.
How we can solve the if you solve that is the roots of this equation? What are that? It is a 2, 5, no?
Yes.
Sir, 2, 5.
X minus 2 into x minus 5 equal to 0. So here solution is clearly we can take that.
Yes, sir.
So it is clearly solution is how much? It is clearly 2, 5. So here already I clearly mentioned second order equation means you should go through that. It is a 2. Sorry, what happened? Something. Okay, 1 second. My screen is visible.
Yes,
Yes.
sir.
Yes, sir.
Okay,
Yes,
fine.
sir.
Here an it is I am finding the roots of this equation. Just now I got it 2 and 5. Correct. Now I want to write the solution. Solution means here one dependent variable an is clearly depends on the 2 terms. What are that? An minus 1 to an minus 2. So 2 constants are required. So it is a C1 into first is a 2 power n is the one solution, and C2 into 5 power n is another solution. So it is adding up these two. I am getting that is the an value. Understood now? I can write this is a way of the identifying of the solution. So here your friend said is that this is every time we cannot go with the substitution for, so that we have some methods in that this is only the left side homogeneous equation solving of that we should be go through this method. Write the quadratic equation or cubic equation. It is depends on the number of terms. Because of it is here how many terms? 2 terms. Degree is 2. So that x square I mentioned. You wrote on the paper on the x square. X square, why you wrote? Here 2 terms are the involved. Here an is clearly depends on the 2 terms. Degree is 2. So that x square. Here is, for example, here 3 terms will have an minus 3. What about that? It is comes to the x cube equation. X cube plus it is a something x square plus something it is a x plus constant. So that is a cubic equation. Cubic equation roots, how do you find? Already you know that till 10th class. So here there you find out the 3 roots. The 3 roots are means 3 constants are needed. So that C1 into that solution what you got it power n plus C2 that solution what you got it power n plus third solution plus C3 plus that solution power n. This is comes to the an equal to this is the finding of the root solutions. Now here after getting this is a correct or not, you should be verify also. So just it is already is a solution. Already we have given the shortcut to how to identify. So simply you take that is and substitute it. It is in this equation. An equal to how much? C1 into 2 power 5n. Next, it is a one-time derivative means 2 power n minus 1 term. Not here, not derivatives here. It is a, but next terms is a substitution. Derivative means it is a next term, a n minus 1. What is next derivative? Next term, it is comes to the n minus 2. So here a n minus 1 and a n minus 2 you should write. So a n minus 1 means it is a 2 power n minus 1 plus 5 power n minus 1. Here 2 power n minus 2, 5 power n minus 2. Now here substitution total, it is a simplification. After that, it is clearly appears that is a 0. Appears it is clearly it is become the 0. This is a overall idea about it here. Finding of the roots. Finding of the roots. Is it clear?
Yes, sir. Yes, sir.
Here, suppose he will give that is a something a naught equal to 10. My continuation I am telling a naught equal to 10. A naught equal to 10 means it is a first a naught you substitute. A naught you substitute. Here a naught equal to how much? C1 plus C2. Here a naught where you should substitute. First of all, you will get that where you should substitute in the solution. Where is the solution? This is a solution. What you identify that solution in that you substitute. A naught equal to C1 2 power 0 plus 5 C2 5 power 0. Something power 0 is 1. So that it is a C1 plus C2 equal to 10. I got it the information because of he gave a naught equal to 10. Next, it is a A1 equal to 41. What is that? N equal to 1, I will substitute. A1 equal to 2 power 1 plus 5 power 1. So C1 2 power 1 plus C2 5 power 1. So here 2 C1 plus 5 C2 equal to A1. A1 equal to how much? 41. I substituted. Now these two equations are solving of that. I will get that is a C1 and C2. How do we solve it? Is a 10th class we know. That is a directly we can solve the two equations. Subtract, multiply 2 and subtract it, you will get the C2. Then C2 you substitute, you will get the C1. So C1 and C2 after getting that before the solution is a general solution, you should write three times of it. This is a particular solution. This is comes to the general solution. What is that? This is comes to the general solution means you should write in terms of C1, C2. Here particular values you are giving for the C1 and C2 finding, so that this is comes to the particular solution. Okay. This is a overall, it is a solution of the recurrence relations, we can say. Is it clear? Next, it is coming to the your choice of that. It is a, this is a linear equation. This is a homogeneous equation. So degrees, it is comes to the here 1 degrees, both of them. That is a already solved in there, solving problems. You can do it. Now I will go for that is a iterative backtracking method. Backtracking method means it is a iteration methods we will be applying. Some of the solutions we cannot be identified directly. At the time, I will go for that. It is a, for example, this is clearly homogeneous case and a non-homogeneous case we can get. Homogeneous case and non-homogeneous. But it's a non-homogeneous case I did not give, but homogeneous case I gave. But here non-homogeneous, how do I solve means we have to go for that. It is clearly iterative methods we should be applying. What is the iterative methods? It is a an equal to an minus 1 plus n. So here an equal to n minus 1 plus n is it is a an minus 2 previous terms. An minus 1 what we can write before terms? An minus 2 plus n minus 1. And before terms what we can write? An minus 2, an minus 3 plus n minus 2. Before terms what we can write? Like
sir,
here,
excuse me, sir. Again, sir. I didn't get an minus 2. Can you please once again explain, sir?
Yeah, you tell me that. What I have written that is an minus 1. Wait. An is a what I have written?
An minus 1 plus n.
Why? Because of he gave that recurrence relation. Number
Yeah.
1.
Yeah.
Number two. N is a limited.
Yeah.
Okay. Now here an minus 1. Based on that an, you should write. From
Okay.
this, you should write this is a an minus 2.
Okay.
Well, nothing I did here. Instead of n, I substituted an minus 1.
Okay. Okay.
What happened? N minus 1 minus 1 means n minus 2.
N minus 2.
N minus 1. So I got it n minus 2 plus n minus 1.
Okay.
Next, we can go for that. It is a n minus 3, n minus 2. Similarly, if it is writing last is a an term. It is an means it is a 1 only. From that, because of a1 equal to 1, he gave by iteration. So that 1. Sum of our n terms equal to what is it? N into n plus 1 by 2. This is what is that? It is a solution of the recurrence relation. This is also one kind of the method for the identifying the solution method. This is a iterative method. Clearly. Next, we can go for that is solve the recurrence relation. This is the most important. Many times you ask the examination. Here an equal to an minus 1 plus f of n. What should I do here? A not equal
Sir,
to
page number 308.
page number. You have to be checking.
Yes, sir. Yes, 308, madam.
Yeah, okay, thank you.
Okay, solve the recurrence relation a n equal to a n minus 1 plus f of n. So here I can go for that a1 equal to a naught plus f of 1 plus a2 equal to a1 plus f of 2. F of 2 means it is here a1 instead of that you can write previous one. Similarly, it is extended up to last. It is a n equal to a naught plus summation of f of k. This is comes to the solution. Comes to the solution. Understood now?
Yeah.
Yes, sir.
Here we can go by that. It is the same way, same recurrence relation, same procedure should be do it. This one already solved in the SAQ. Already it is a solved problem will be there. You can check. Next, it is a one more. It is a generalization. Here, three pegs. It is a tower of honey problem. We called as the tower of honey problem. Tower of honey problem means it is comes to the here an equal to 2 times of a n minus 1 plus 1 is called as the tower of honey. Now, in this, this is just you read it. Now, how I will be solved? That is comes to the here. First, here back substitution. If I iteration method, if I apply, I can go for that. This is a way I can get that to all the terms. What is the sum of n terms? It is comes to the a n equal to 1 minus r to the power of n because of geometry series. So 2 power n minus 1. A n equal to 2 power n minus 1. This is comes to the our required solution. Is it clear? It means that one theoretical problem, it is the nature of the problem, we will be converted into the mathematical problem. That mathematical problem conversion clearly to explain that a n equal to 2n minus 2 times of a n minus 1 plus 1. So here we can solve by using the geometric progressions. It is directly we can get that is a solution is a to a n equal to 4n. Now it is coming to the solve that is a n equal to, this is the most important, 18.4.5. Many times you asked in the exam. Similar procedure I will be adapted for that. It is a previously what I have to substitute. Same I substituted. Similarly, going through this substitution, adding of all, I am getting that is a this is a term a n equal to a n minus 1 plus n minus 2 plus so on like that up to n minus 2 power 2 plus so on like that 2 power n minus 1. This is a back substitution, all iterative steps. Carefully, you should be checked. Then after that, this is a total a n is a sum of n terms. We cannot write so that leave it that directly you can write that is all the terms. Because of adding of all, I am getting the same solution. Adding up all I am getting, so that this is one of the way for that how I will get the solution. Next, just now I mentioned that characteristic method. What is a characteristic method? Means it is a based on the degree. I said that you write x square plus x cube plus like that. So also I am saying that it is a we can write that is a this is considered recurrence relation. Is it the homogeneous or non-homogeneous?
Non-homogeneous.
Non-homogeneous. So here solving of non-homogeneous, first you take that is the left side term is equal to 0. Homogeneous solution you should identify first of all.
Yes.
So homogeneous solutions if I identify, I can get that is a this is a equation. Solving of that I am getting that is the roots are the this is a 3 cases are the roots we can get. What are that real and distinct? 2 roots. At example, I am taking the 2 roots. Real and distinct, real and equal, and real and complex. Here, 2 are the real roots will be there. I said that is a R1 is a previous problem I explained. It is a you identify that is a 2 power n plus 5 power n. So R1 equal to 2, R2 equal to 5. This is a real roots. This is comes to the real roots, real and distinct.
Okay,
roots.
okay.
Now here, same procedure. If I solve this problem, real and distinct problem, I am explaining here. What is it? An plus an minus 1 plus 6. This is a roots I identified that and solved that. I am getting that the final result is an equal to 2 power n minus 2 into minus 4 to the power of n. Directly you can go to the procedure. What I explained the previously. Sir, where is that is the characteristic equation? This is a characteristic equation because of r square plus r minus 6. Why? Because of here it is a an is clearly depends on the 2 terms. What is it? An minus 1 and an minus 2. So r square plus r minus 6. This is a after finding out the solution, it is a initial condition he gave. That is a naught equal to minus 1 and equal to 8. So solve and substitute. This is one of the recurrence relation unique solution. Okay. Now here same another is a solve the recurrence relation of this term. This is also important. Now I will get that is a complex roots. Okay. If I get that is a complex roots, here these two terms take the left side. Left side. Right side terms are making it to the left. What happened? It is a minus term. So it is minus r. Minus r. Here Fn equal to its coefficient is -1. You can ask that, sorry, this is a we start from the an minus 2, an minus 1 like that. No need. It is a I start from the an and an plus 1 and an plus 2. So that is also recurrence relation. I want to identify an plus 2. So this is the way of approach for that. So that it is a this is a complex roots I can get from the above equation I will solve. Sir, it's mentioned that there are no constants. Why will say that it is a coefficients are there 1. Here also coefficient is 1. So r square minus r minus 1. So r equal to 1 plus r minus root 5 by 2. So here Fn equal to here r 1 plus root 5 by 2 whole to the power of n, 1 minus root 5 by 2 whole to the power of n. Now initial conditions, if I substitute, what is the initial conditions? He give that Fn equal to 0 and F1 equal to plus 1. Directly I will substitute it and I can get that C1, C2. C1, C2 I will substitute here. C1 equal to 1 by root 5 and C2 equal to minus 1 by root 5. This is the most important term. These 18.5.4, 18.5.5 also equal. Clear? That's it.
Okay, sir.
Now we go for that is a example, another example. Here, sometimes it is comes to the irrational. Here, see here, this is comes to the an equal to this type of equation. What I can
page number?
Page numbers, I cannot say the continuation only. 18.5.6.
311.
Okay.
311.
Now we'll continue. Now an equal to 10a n minus 1 plus 29 a n minus 2 and a1 equal to 10 and a2 equal to 1. So this equation is I can write like this. It is the left side terms I am sending the right side, these two. Here r square minus 10r minus 29 equal to 0. You can ask, sir, actually here is it the mistake or did he give the like this only? Yes, actually here small an we having some small printing. Okay. Now here sometimes he may give that is a in the exam also an he will give. At the time, this is a sequence term so that your representation is a an, but it is a small an you consider and do the problem. Okay. So here r square minus 10r minus 29 equal to 0. So what happens? It is the roots are the 5 plus the irrational roots. So that it is also your irrational roots also you should write that is a power n only. Okay. Now here already it is a initial condition and we give a1 equal to 10, a2 equal to 100. Just you substitute you can get that as a solution. Is it clear?
Yeah, sir, finding the roots is like minus b plus or minus root.
Yes, you can go by the same minus b plus
Quadratic equation formula. Okay.
4ac by 2a.
Okay.
Now we will go for the solve that is a recurrence relations. Recurrence relations are the an plus 3 minus equal to, here this is a cubic equation. Cubic equation. So here what I am getting that is a 2r cube minus r square equal to 2r plus 1 equal to 0. Now these terms are the taking the left side. What are the roots? I am getting that is a characteristic roots are the 1 minus 1, 1 by 2. These are the three. So here I am getting that is a C1, 1 to the power of n. 1 to the power of n is 1. So that no, I did not write here. We did not write here. Plus C2 minus 1 whole to the power of n plus r minus 1 whole to the power of n and another root is 1 by 2 whole to the power of n. These are the roots. Now it is a conditions at the satisfied. So here I will substitute C1 equal to 5 by 2, C2 equal. This I can get the constants by the given conditions. What are the conditions? A not equal initial condition.
Equal 0.
A1 equal
A1
0.
equal 1.
3 equations we can get. Solving of that we can get the C1, C2, C2.
Okay, sir.
Example he gave this one. These two already solved in the case. Next, if I get that is a repeated roots, what should we do? Repeated roots we will get means it is a, see here, a naught r to the power of n. Example 2, comma 2, I got it for example. Comma 2. Roots are the 2. What should we do? C1 2 power n plus a1 into n into 2 power n. N into 2 power n. Okay. Here, second term take the n. Third term goes to the 3 roots are the equal. 2, 2, 2. Then it is a a2 n square r to the power of n. Okay. 4 terms are the equal. Then we can go for n cube r to the power of n. Like here, we can go for that is a generalization repetitions. We can go ahead. Continuation. This is comes to the here real and repeated roots. Real and repeated roots. So generalization we can take it is a n into r to the power of n plus a1 n into r to the power of n. A m minus 1 n into r to the m n to the power of m minus 1 r to the power of n. Like that it is a0 a1 a2 so on arbitrary constant. These constants are determined using the initial conditions. Next, solve the recurrence relation. The recurrence relation. Here, an plus 2 equal to 4 an plus 1 minus 4 an. An plus 2 equal to 4 times of an plus 1 minus 4 an. This is a another example. Another question. How many roots are there? 2 roots. Roots are the equal. So here we can write that as a solution is a an equal to this one. C1 2 power n plus C2 n into 2 power n. Now initial condition he gave a0 equal to 1 and a1 equal to 3. Solving of that I am getting C1 C2s. Is it clear? Understood?
Yes, sir. Yes, sir.
Yes, sir.
Now I will go for the 18.5.11. Here also these are the roots unequal 2.5 and a2 equal to 4.7. Now solving of this it is x square minus plus 6x plus 9 equal to 0. Because of left side minus will be there. Going right minus will be there. Going left side is a plus. So that x square plus 6x plus 9 equal to 0. Now solving of that roots are the an equal to c1 minus 3 whole to the power of n plus c2 n into minus 3 whole to the power of n. Here initial condition I will substitute. Here I will get that is a solution. Next part 3. 2 are the completed. Roots are the real and distant and roots are real and equal. Now I am coming to the complex roots.
Complex roots.
So what is it? C1 R1 equal to R cos theta plus R sin theta. So here I will find out that it is a of R1 I will write R1 cos n theta, R to the power of n cos n theta. Instead of R2 I will write R2 R power n into sin n theta. So here that you can write like that. It is a one is a plus term will be there, another is a minus term will be there. Okay. So here generalization if I write it is a n equal to here's r to the power of n into k1 into cos n theta plus k2 into sin n theta. If he writes is enough. Sir, example. We'll go for that is a n equal to 2 times of an minus 1 minus an minus 2. And initial conditions are a not equal to 1 and a1 equal to 2. So what are the roots? It's r square minus 2r plus r plus 2 minus 2r plus 2 equal to 0. So 1 plus r minus I is a 1 root. So 1 plus I whole to the power of n and 1 minus I whole to the power of n are the two linearly independent solutions. Now here an equal to c1 into 1 plus I whole to the power of n, c2 into 1 minus I whole to the power of n. Is it clear? Just it you substitute it is enough. If it is needed that you can identify the form of this one. Form of this one. What is that? It is a root 2 whole to the power of n. Why? Because of modulus. Modulus of 1 plus I equal to root of a square plus b square. So that it is a root minus root 2 and it is a b by a. Tan theta equal to b by a. So theta equal to pi by 4. So that it is a cos pi by 4 plus I sin pi by 4. Now here minus will be there, this one minus. So that it is a common term. This is a common term. This is a solution means it is a an equal to root 2 whole to the power of n into k1 into cos n pi by 4 plus k2 into sin n pi by 4. Next it is a k1 k2. It is the initial condition he gave. That initial conditions are the a not equal to 1 and a1 equal to 2. Substituting that I will get that is a roots. It is a c1 c2 so I can get I will substitute it. This is our required answer. Another example goes to the this is a an equal to this is the most important. An equal to b into an minus 1 minus b square into n minus 2 for n is greater than or equal to 3 and a1 equal to b and a equal to 0. Now solving of that an equal to c1 into this is our required solution. And recurrence relations we can write by using this one. Examples you can take this one. Now this is comes to the recurrence relations. This is a total is concept of recurrence relations. Now I am going for that is a new topic is comes to the generating functions. Generating. What is a generating function? First of all, it is a generating function is a linear equations we can write. What is the linear equations? It is comes to the a0 x power 0 plus a1 x power 1 plus a2 x square plus a3 x square plus a2 x square plus a3 x cube plus so on. Here, like that, it is a linear equation we will write. That linear equation in this generating the sequence terms are the coefficients. Coefficients is a recurrence relation. Coefficients is I am taking a1, a2, so on. Next, it is a this is a form we can write that is a x power a k into a power k. This is comes to the one of the function form. It is a summation of x to the power of n plus k form. If we write that, this comes to the generating function. We call as a generating function. Simply, it is a generate the sequences.
Okay.
Here, previously, we discussed the sequence. The generating function means generalization for the generating function. We have to do. This is the generating function applications. Sir, when is this needed? It means it is a 1 by 1 minus x will be there. What I can write generating function? Summation of n equal to 0 to infinity x power n. That is a generating function. What are the coefficients of the sequence? 1, 1, 1, 1, 1, all we can get. So this is a generating function. Here 1 by 1 minus x is the function. That function. Here, for example, here x by 1 minus x will be there. What I can write, it is comes to the, this is the generating function. Next, x square into 1 minus x whole power minus 1. Like it is, we can write that is all the generating functions. Clear? This is the overall idea about the generating functions. Now here, sir, it is a generating functions. Can we here? These all we the show that already exercise we solved that all. Now I'm taking the one of the problem is a 1 by 1 minus x whole to the power of 4. I am checking here. Example. What I can write means it is a c n plus 3 4. No 4 minus 1 how much? 3 plus 3 comma n. C combinations of n plus 3 cn n plus 3 cn. Short box. Here. What is that? It is a generating function. Here, C n plus 3 terms. I am selecting that is n terms. So n plus 3 Cn, n plus 3 Cn x power n. That is comes to the here generating function. Directly I can write that 1 by 1 minus x to the power. Similarly, I can go for that. This is a example generating function we can write. The solving of that. These all are the problems we can be solved. Okay. Principles of generating functions. Principles of generating function means generalization we will write. That is called as a principle. First principle is a generating function. Okay. 1 minute. Charging better. Charging this little bit better. Okay, right. Here, other shifting properties of generating function. Amma, here, generating function, how we can be generated here, just now I explained. Yeah, this is comes to the here generating function development. It is comes to the comes to the here 1 by 4 is the summation n equal to 0 to infinity n plus 3 combinations of n. So n plus 3 cn x power n. This is a total generative function we can write. This is a simplification. Now here terms if I write here last it is a terms will be there. No? The terms if I write like this, it is a we can write like this. So here, that all in terms of r. R will be the, it is a simplification. If I follow that is a simplification, r cube, r square. So total simplification, how many terms we have all. These all are the roots. Then this roots is a simplified, that is a, this is a way of approach for that is a how I can get that is a recurrence relations. Yeah, recurrence relations. So, sir, how recurrence generating function will be helpful for us? Means it is a generating function, simplifies into the terms of the single terms. It is a powers of 2s and 3s, and it multiplies to it. It is a sequential form. It is easily to understand, and next performance of the things we can be observed easier. Now coming to the other shifting properties. Coming to the other shifting properties. In this other shifting properties, generating function, if I take, it is comes to the a of x equal to summation of an into x power n generates, it is the a naught. So these all comes to the generating functions. Next here, tabulation form. Sequence will be there and generating function you should remember. And whenever you will ask the generating function, you should be remember this is the generating functions. So solving of this problem, sir, how I will be solved? Mainly it is an examination. You will ask like that. It is a, by using the solve the recurrence relation by using generating function. Previously iteration procedure. Okay. Next characteristic equation solving. The two methods come. Now he will ask that is a solve the recurrence relation methods. Recurrence relation method means it is a simply take that is a ax and substitute it and solve it. We can get that is a ax. Ax is this simplify it. We will get that is a generating function. Yeah, previously what we got it is the same c1 into 2 power n plus c2 into 5 power n generating function. So that summation of x power n generating function. So that summation of x power n. Here like here we will substitute that it is a an here substitution of n equal to 0 and n equal to 1. We can get that is a constant solving with based on the initial condition. Similarly, we can solve this is a important number 18.6.3 and 6.4 are the important. Same procedure we should be solved with these all. Okay. Yeah, 18.6.5 also same generating function. Non-homogeneous. Non-homogeneous means it is the first left side you should be identified. Then you go for the right side identification point of view. Here right side, left side is already we got it. That is a left side recurrence relation solution. One is a 3 power n will be there, and another is a 7 power n will be there. So here 7 power n that will be solved by using the initial condition. By using the initial condition only we can be identified. Then we can substitute it. That once you check, you can get that answers. Non-homogeneous also very easier. Okay. This is a model questions here we have in the bottom that you can be solved. These are the problems will be there, and already answers also bottom will be there. You can see. Any more queries? Yeah, today I explained. Thing is what is the recurrence relation? What is the sequence? What is the recurrence relation? Solution of the recurrence relation. Homogeneous or the order of the order or degree both are same because of polynomial. So here degree of the polynomial, degree of the recurrence relation, and characteristic equation of the degree. Then it is a homogeneous recurrence relation, non-homogeneous recurrence relation, and it is a various kind of the roots. The real roots, real and distant, and real and equal, real and complex roots, and irrational roots. These 4 types, it is a solutions I explained. And a non-homogeneous case only one. It is a iteration method I explained. And a general method, generally it is a characteristic method I explained. And using the iteration method I explained. And last one is a generating functions we discussed. Then after that, it is a non-homogeneous also. We go through the same procedure. This is a today class. In this Anyway, we will meet in the next session tomorrow. And I will, the one topic is completed, 18th complete completed. Plus I will.
Sir,
I will end up the session. We meet in the next class.
sir,
Please.
explain about assignments, sir.
Assignment.
Assignment process. How do we write assignments process? Sir?
Already assignments questions will post by our coordinator madam to the your.
Sir, if possible, please explain assignment question and answers.
Assignment questions, madam will send you. That questions
Yes, sir,
you have to be
please,
right referring the textbook. You write
If
in the
possible,
paper.
please explain, sir, question and answers.
Question and answers I can't explain. You should be referring the textbook only. Because of your, I have to complete the syllabus. You have any doubt, I will explain. But it is all the assignments questions I can't explain. Okay.
Sir, single assignment give 4 questions. We can choose only 2, no, sir?
That all guidelines will give by our coordinator. I don't know, that all will be given by the guidelines given by the coordinator, madam. You follow that same guidelines. Any doubts on the topic, you ask me now.
Okay.
Already, madam, given that is one group. In that you can request, madam. Okay.
Sir, we know, sir, all the question papers we know, but how do we write a step-by-step process? We don't know, sir.
You mean, okay, we'll discuss in the next class. Okay. I will wind up the session. We meet in the next class. Next class, I will tell you. Okay.
Okay, sir. Thank you, sir.
Okay, right.
ఇక్కడ ఉన్నవే చెప్తుంది అలాగే అలా చెప్తే చదువుకుని వెళ్ళిపోయాడు ఆయన. 1 by 1 స్టెప్ వైజ్ గా వెళ్ళిపోవడం. అదే అమ్మాయి అడుగుతుంది కదా, గ్రూప్ ఏదో క్రియేట్ చేశారట ఆల్రెడీ. అంటే ఇక్కడ ఉన్నదే అని తెలుసు, కానీ ఏ స్టెప్ వైజ్ గా ఫామ్ లో రాయాలి కదా, 1 by 1. అంతా రాసుకొని కూర్చోరు. అంటే రికార్డులే ఉంటాయా, ఏముంటాయి దీనికి?
Yes.